Uh, our first example will be how to use a means procedure step to perform simple t-test. Suppose our input data is here, the count data. Our null hypothesis would be whether the mean of the ring variable is 10 and the mean value of the yield variable is 30. So after we do our data step and our input statement, we create a new variables of ring 1 and yield 1, where ring 1 is the ring variable subtracted by the supposed true mean, and the yield 1 is the yield variable subtracted by the assumed true mean of 30. So then we begin our input here. Then we would like to move on to the ring procedure step uh, with these following options. N as the total number of observations, mean is the mean, standard deviation, the t statistics, and the corresponding p-value for that t statistic. Then we run this chunk of code. Yes, we could see the corresponding t-value and the corresponding p-value here for those two variables. They are under the 0.5 level of significance value. We could like make the conclusion that the yield one won't have a mean value of 30, but the ring variable, we will not reject the null hypothesis that the mean of it would be only 10. Then we will do our second example of performing a paired sample t-test. Assume that we would like to find out whether the value of summer and spring would be different. So after our data step and our input statement here, we would like to create a new variable called change, which is the difference of summer and spring. So after our input step, we would like to run the same mean procedure as the first one. Now run this chunk of code. Therefore, the small p-value indicates that there's going to be a significant difference between the value of summer and the value of spring. Our third example is about how to do two-sample t-test, um, where we would like to use the t-test procedure statement. So we will still use the count data as the first one, but we are going to transform our ring variable to a factor one, to a factor variable. So we set the original data set and we create a new variable called cat ring, which only takes two different characteristic values. So if the ring is smaller than 9.7, then the factor variable cat ring will be jout. Otherwise, it will be normal. So basically, we are transforming this ring variable to a factor variable. Uh, and so after we do the modifications of the variable, we create a new t-test procedure followed by the name of the data set. And we will use the class statement to specify the factor variable. And after the var statement, we choose the variable we would like to analyze. Then we run this chunk of code. Wait a minute. Uh, we first have to read this part of the table, which will test the equality of variance for those two samples. The very large p-value indicates that we will not reject the null, we will accept the null hypothesis that the variance of the two samples are equal. So when reading the t-statistics table, we will move on to the put method, we treat the variance of those two groups as equal, and read the t-value and p-value on this line. If the equality of variances table shows a very small p-value, we are going to reject the hypothesis that the variance of those two groups are equal. Basically, we can make the conclusion that the two groups will have different variances. Then we will move on to the Satterthwaite method. We treated the variances unequal and read the t-values and p-values here. Our Next, we will move on to how to do one-way ANOVA for a certain variable. So our original data will include these variables, where the vehicle type here is a factor variable. We are taking on several different numerical values as 1, 2, or 3. And the variable we would like to analyze is the response time. So after we loading our data, we would like to use the ANOVA procedure step to analyze how vehicle type will affect the value of response time. So it was much similar to the t-test procedure. We first set our data set, and after the class statement, we will identify the factor variable which we will use to classify different kind of observations. Then we will have a new model statement with the left-hand side as our dependent variable, namely the variable we would like to analyze. Here in this example, the dependent variable is response time, and on the right-hand side, we will have to specify the factor variables which we believe will affect the value of the dependent variables here. So after the model statement the model statement will then be followed by a mean statement, where we have to specify our factor variables and the methods we would like to choose to analyze our data. Then we run all this chunk of codes. Yep. Therefore, judging from the f value here, it is very small, which tells us that the response time will be much different across different groups of vehicle types. We can also see the pairwise comparison of different groups, where the significance level tells us the only significant difference occurs between the first group and the second group. Now, again, we would like to show that we can both do t-test using the GLM procedure step and the t-test procedure step. So here we would like to find out whether there's going to be significant difference in response time for vehicle type 1 and vehicle type 2. We first run a new data step to select the subsets of the original one, which only includes observations with vehicle type 1 or vehicle type 2. Next, we would like to show how GLM procedure will do the t-test. We still set the data set as before, and we use the class statement to specify the factor variable, and we'll also use the model statement with the left-hand side as the dependent variable, and the right-hand side as the independent variables or the factor variables. The t-test statement is same as before. Then we would like to run this chunk of code to see how these two procedures will perform. Just wait. Yep, from the GLM procedure, we will find out like we will have a very big p-value, thus somehow rejecting our null hypothesis, which will like accept our null hypothesis that the response time for those two classes are the same. And then we would like to move on to the t-test procedure, which much yielding the much similar results with a very big p-value, which will somehow um, reject our null hypothesis or accept our null hypothesis. There is a group mean of vehicle type 1 and vehicle type 2 will be the same. Our final example is about to do two-way ANOVA. Basically, in two-way ANOVA, we'll have to include several different factor variables, as well as we might consider the interactions between different factor variables. So we first have to input our data, which have those following variables. And the factor variables here is a species and the impactor as our factor variables. And we would like to see how these two factors will affect our numerical variable of STIF1. So we still have several methods to do two-way ANOVA. We first will use a GLM procedure with our name of data set. Then we use the class statement to specify our factor variables, where in this case it's a species variable and the impactor variable. Then we have to specify our model, which is the left-hand side is still our dependent variable as STIF1, where we have to include all our factors on the right-hand side. Here, we are considering both the marginal effects of the two factor variables, species and impactor, and also an interactive term of the mutual effect of species and impactor, which is here like, but always keep in mind, do the individual effects of the factor variables first, then follow it by our interactive terms. Then we have to still use the mean statement. First, we have to specify our factor variables and also specify our method to do ANOVA. Then we run this piece of code. What's happening here? Do it again. We have to, oh, somehow have made a mistake in the name of the file. Then we move on to our two-way ANOVA table. Let's see the result of it. Yep, here. This is the summary table of the two-way ANOVA test for the dummy data. We will log on the p-values of the individual factor species, which is somehow 0.07, still greater than our 0.05 level of significance. And the p-value for the impactor factor variable is very small, and the p-values for the interactive term is somehow very big. So judging from the table, we could make the conclusion that only the levels of impactors will indeed affect the value of stiffness. Therefore, from our GM procedure, only impactor will affect STIF1 based on our conclusions here. After we do the ANOVA, we still have to check whether the model is misspecified or not. So begin with the same GLM procedure with the same class statement and the same model statement. We would like to output our results to a new data set, which we name it as new, and we name y hat as our predict values for different groups, and resid, this variable, to be our residuals from our ANOVA test. So to find out whether the model is good or not, we first would like to plot several residual plots. So we use a plot procedure with the data set as our new create one from the previous GLM procedure step, and we would like to plot several plots. First one is residual against our predict value, residual against the factor variable species, and the residual against the factor variable impactor as before. Another thing we would like to check is whether the data is normally distributed. So we will use the proc univariate procedure step as we have talked about in lecture 2, and use the options both normal and the plot. And we set the new data set new, which we created here, and we choose a variable we would like to analyze, which is residuals from here. Then we run this chunk of code. The same ANOVA summarizing table is the same as the first one, with the safe level of p-values, which somehow giving the conclusion that only impactor will affect the value of Steve1 variable. Then we like to see the following plots. First one is like the residuals against our predict value, and our residuals against our different predicted values, and our residuals against the first factor variable, and also residuals against our second factor variables. So we could see like that the residuals against both like predict values or those factor variables is somehow symmetrically distributed. That which means like our model is somehow very makes sense. Then we will move on to the normality test on the residuals. So from the quantile plot, we could find out that the residuals is almost like a straight line against the normal quantiles, which tells us like the residuals are somehow normally distributed, and our normality assumptions is correct for the original data set.